G'day! Airports are busy places. Statistics are used to ensure that passengers are on time. Today we'll learn how to calculate some important statistics like these. Let's get started. This table shows the times between check-in and take-off by passengers at an airport. 3 people check in 1 minute before take-off, 8 people check in 2 minutes before take-off, 6 people check in 3 minutes before take-off, 4 people check in 4 minutes before, and 2 people check in 5 minutes before take-off. There is a total of 23 passengers in this example. We write this at the bottom of the frequency column. In real life, airlines use the data of thousands of travellers, but we'll only use small numbers in our example. Also in statistics, we use symbols. X is the symbol for the time, F is the symbol for the frequency. That's the number of passengers. The total or sum of the passengers is called sigma F, where sigma is the Greek letter that means the sum of, so sigma F means the sum of the frequency. Now let's calculate the cumulative frequency. Have you heard of the word accumulate? Well, cumulative means to accumulate or to add up. So we add up the frequencies or the people like this. In the first row are the 3 people who checked in only 1 minute before takeoff. In the second row are those 3 people plus the 8 people who checked in 2 minutes before takeoff. That's 11 people so far. In the third row there are 17 people so far. In the fourth row there are 21 people who checked in 4 minutes or less before takeoff. And in the last row are all 23 people. Now we'll find the median. The median is an average. It's the middle number of a set of ordered data. It's halfway through this data. In this example, the median is the time when half of the passengers have checked in. Here is the rule to find the median. The median equals the sum of the frequency plus 1 and then divide that by 2. So 23 plus 1 divided by 2, that's 24 divided by 2. So the median is the 12th passenger's time. Let's look at the table. Here is the 12th passenger, and their time is 3 minutes. The median means that the slower half of the passengers had checked in 3 minutes before takeoff. Now we'll find the first quartile. It's 1/4 of the way through the data. In this example, the first quartile is the time when the slowest 1/4 of the passengers have checked in. Here is the rule. The first quartile equals the sum of the frequency plus 1 and then divide that by 4. That's 23 plus 1 divided by 4, 24 divided by 4, so the first quartile is the 6th passenger's time. In the table, here is the 6th passenger and their time is 2 minutes. That means that the slowest 1/4 of the passengers had checked in only 2 minutes before takeoff. Now we'll find the third quartile. It's 3/4 of the way through the data, or the time when 3/4 of the passengers have checked in. Here is the rule. The third quartile equals the sum of the frequency plus 1, then divide by 4 and multiply by 3. The third quartile is the 18th passenger's time. In the table, here is the 18th passenger and their time is 4 minutes. That means that 3/4 of the passengers had checked in the 4 minutes before takeoff. Tables are one way to look at data, and graphs are another way. Let's draw the cumulative frequency graph. It's also called an ogive. We'll move this table to make room for the graph. The x-axis is the time in minutes. The y-axis is the cumulative frequency that goes up to the total of 23 passengers. Let's go up by 5s up to 25. Now we plot the points for the graph. 1 minute before check-in matches with 3 people. 2 minutes before check-in matches with 11 people. 3 minutes matches with 17 people. 4 minutes matches with 21 people, 5 minutes matches with all 23 people. And here's the ogive. This final example shows the number of bags checked in by passengers. We will do the same statistical calculations as in the first example, but in this example we'll do one extra step. We will use percentages. Let's get started. This table shows the number of bags checked in by passengers at an airport. 10 people have no bag at all. 14 people have only one bag. 6 people have 2 bags and 5 people check in 3 bags. There is a total of 35 passengers in this example. We write this at the bottom of the frequency column. Now let's calculate the cumulative frequency. We add up the frequencies or the people like this. In the first row are the 10 people who have no bag. In the second row are those 10 people plus the 14 people who have no bag or one bag. That's 24 people so far. In the third row are 30 people who have either no bag, one bag or 2 bags. And in the last row are all 35 people. We'll add another column for the cumulative percentage. In the first row, there are 10 people out of a total of 35 who have no bag. We multiply this fraction by 100 to calculate the percentage. The people who have no bag is 29%. In the second row, 24 people out of 35 have either no bag or one bag. That's 69%. In the third row, 30 out of 35 people have either no bag, one bag or 2 bags. Multiplied by 100, that's 86%. The last row has all 100% of passengers. A graph called the cumulative percentage ogive is another way to see the data. We'll move this table to make room for the graph. The x-axis is the number of bags. The y-axis is the cumulative percentage that goes from 0% to 100%. Let's go up by 20s. Now we plot the points for the graph. 0 bags matches with 29%, 1 bag matches with 69%, 2 bags matches with 86%, and all 3 bags matches with 100%. Here's the ogive. Last, we'll find the median from the graph. Remember that the median is 1/2 or 50%. The median number of bags carried by half of the passengers is about 0.5 bags.